Hi everyone, this is TLE Eliminators and I am Soumojit Chatterjee. Welcome to the post-contest discussion of today's Codeforces contest. I sorry for the delay. Actually, there was some problem with the Meet link. Some people were not able to join and I was also facing issues with the mic. I understand that it is irritating to wait for so long in this night, but I hope you bear with it. So we will start now. Just confirming once I'm audible and my screen is visible, right? Anyone in the chats?
Yes, sir.
Thank you. Okay, so let's start without much delay. Okay, so this was the problem A of the contest. It says shape perimeter. So it asks that there is an m by m square stamp on an infinite piece of paper. Initially, the bottom left corner of the square stamp is aligned with the bottom left corner of the paper. You are given two integer sequences x and y, each of length n. For each step I from 1 to n, the following happens. Move the stamp xi units to the right and yi units upwards. Press the stamp onto the paper, leaving an m by m colored square at its current position. Note that the elements of sequences x and y have a special constraint. Xi and yi lies between 1 till m minus 1. Okay. Then it says that note that you do not press the stamp at the bottom left corner of the paper. Refer to the notes section for better understanding. It can be proven that after all the operations, the colored shape on the paper formed by the stamp is a single connected region. Find the perimeter of this colored shape. Okay, so let me explain what does the problem says. Okay. So here it is. The problem gives us as input n pairs of values, say x1, y1, x2, y2, and this goes till x and yn. And it also gives us an integer m, which is basically the size of the stamp. So this is the size of the stamp. And this m depicts the size of the square. So by m, basically you means that you have a square stamp. So you have a square stamp where this length is m and this length is m. Okay. Now what does the question says? The question says that these are basically the shift values. At every step, you shift the square by these margins, say x1 x1 in the x direction and y1 in the y direction. You keep on shifting and you need to find the perimeter of the shape. Let me explain this. So basically something like this. So suppose this is my coordinate system. This is my y-axis. This is my x-axis. And the question says that suppose the initial values x1, suppose the initial values are x1 and y1, then basically at first you shift the stamp at, and suppose this is x1, this is y1. Initially the stamp was at origin, it has been said. The bottom left corner of the stamp was at origin. You shift it so that the bottom left corner is now at this coordinate x1, y1. So how does the stamp look like? The stamp looks like an m cross m shape here, right? So this is m and this is m and it looks like this. Now at the next step, what do? You shift the coordinates by x2 and y2. Okay, so how does it look like? You basically shift this, you shift this coordinate by x2 more. So this distance is x2 and now the new x coordinate is somewhere here. Similarly, you shift this by y2 more and the next direction, next coordinate is something here. So this is my new coordinate after the shifted position. So this point is the new bottom left coordinate basically. So now how does the stamp look like? The stamp looks like something like this. Okay. Now, basically, the question says that whenever you put a stamp somewhere, this area gets filled with ink. So initially, this area got filled with ink. Now, since you moved the stamp, even this area got filled with ink. And slowly, and similarly, you keep on moving the stamp. So the stamp keeps on moving depending on other x3 and y3 values. It keeps on moving like this. And you finally need to find the perimeter or the boundary length of this entire area which has been covered with ink. So basically, what length do you need to find? You need to find the length of this region. Like it starts from here, it goes here, it starts from here, it goes here, it starts from here, it goes here, and then it comes back like this. So basically, this is the perimeter of the region, right? The boundary. And this is what you need to find. Even if you can look an example, they had given a diagram here. So these are the x and the y values. Similarly, the stamp has moved like this, and then you need to find the perimeter or the length of the boundary of this entire connected region. Okay. So is the problem statement clear? Can someone confirm?
Yes.
Okay, thanks, Aman. Now let us try to understand how can we solve this. Okay. So first of all, try with smaller test cases, and then we will try to extend the logic on a larger test case. So suppose this is my y coordinate and this is my x coordinate. So initially, suppose initially, suppose this was 0, 0, and I shifted it to somewhere at x1, y1, right? So this distance is x1, and this distance is y1, and I shifted it such that the new stamp paper looks like this. So suppose the value of n is just 1. If the value of n is just 1, that means we do not shift it further. Then what should the answer be? Anyone?
4m.
Great, great. So if the value of n is 1, then the perimeter is simply the perimeter of the square. Now, so it is simply the perimeter of the square. This is an m by m square. So basically, the perimeter is simply 4m. Now suppose I shift it again. So if I shift it again, so basically I shifted by a distance x2. So this is x2. So I keep it somewhere like this, so at this position. And I also shift y2 here. So this value is y2. And this is my new coordinate. So here is my new coordinate basically. So now my stamp paper looks something like this. This is again an m by m square. Okay. First of all, I would like all of you to observe that this constraint, it has been given that xi and yi lies from 1 till m minus 1. This is given just to make the problem simpler. That means at any point of time, there will always be some overlap between these two squares, right? Because this value of distance x2, this distance x2 is less than the entire length of the square m. So that means when you shift, then this shift is actually lesser than this entire length of the square. So there will always be some area of overlap between the square and the newly shifted square. Okay. So how will you find the perimeters? So basically, don't you think that we have two squares, right? So if we have two squares and we need to find the perimeter, so the perimeter, so that is, suppose let me call this square S1 and let me call this square S2. So perimeter of this entire shape, isn't it simply perimeter of S1? Perimeter of S1 plus the perimeter of S2 minus some duplicate region, right? Minus duplicate region, basically something's minus the duplicate boundary, something which we have counted twice. Basically, what do I mean? I mean something like this, that suppose I have two squares. So I have this square 1. So this is a square, and suppose this is also a square. I need to find the perimeter of this shape. What do I mean when I say that I need to find the perimeter of this shape? I basically need to count this length. So I need to count this length. I need to count this length. and then I have to count all these remaining part, isn't it? So this entire length needs to be counted. So what I'm saying is, or what I'm suggesting is that why don't you add up both the perimeters? Like if you add up both the perimeters, you count basically this entire thing, you count this entire length, boundary length once, and then you count this entire boundary length again once. So what is the sum of the perimeters? The sum of the perimeter of S1 is 4m. The sum of the perimeter of S2 is 4m. But then look at this. When you calculated 4m for S1, you took this extra part. So you look at this part. So this part was something which is not a part of the perimeter. It comes inside the region, but still you have counted it in this 4m. Similarly, look at this part. When you actually counted the perimeter of S2, you added up the length of this part, which was not required as it comes inside the region, right? So we need to find the length of this entire thing because this is something which we have overcounted in 4m plus 4m. The rest of the entire thing is clear, right? Okay. So let me call this as H, this is H, and this is W. So basically the answer is 4m plus 4m minus 2 times H plus W, isn't it? So if I somehow find the value of H and W, then I would be able to find the perimeter of the entire shape. Great. So now the question is, what is H and what is W? Anyone in the chats? What are H and W? Any guesses? Okay, Aman says X or Y. Let us see how. So basically, I had this square, right? So I had this square, and then I had this square. Great. Now I need to find, so I call this as H and this is W. So I need to find what is H, right? Now look at this length. What is this length? This length is nothing but how much distance x has shifted, because this was initially my x and it has shifted by this to get here, right? So that means this is nothing but my xi. So this length is xi and this is h. So that means xi plus h, that is nothing but the length of the side of the square, right? So xi plus h is simply m. That means what is h? H is m minus xi. So what is h? H is m minus xi. By a very similar logic, if you look at this distance, this distance is simply yi, right? Or basically look at this distance. This distance is simply yi. This is the distance the y coordinate has shifted, because the y coordinate has shifted from here to here. So if this distance is y and this is w, and this total length is basically the length of the side of the square, that is m. So this is yi, this is w, and the total length is m. So we get a similar expression that yi plus w is m. And so we can write that w is nothing but m minus yi. Is it clear? Simple geometry. The values of h and w. Yeah, Amit, you were right. It's m minus x and m minus y. So that means that if I had just two squares, then the perimeter is simple to calculate, right? It's nothing but 4m plus 4m minus 2 times h plus w, which is nothing but 4m plus 4m minus 2 times m minus xi plus m minus yi. Great enough, as easy as it seems. Now, what if there are multiple squares? So what if the value of n is large? So I had some square here. Okay, let me draw it in one more page. Okay, so I had some square here. Then I had again one more square here. And then again I had a square here. All these squares are of same length. They are m cross m squares. And the value of shifts are known, right? So this distance is known. This is nothing but x2. Similarly, this distance is known. This is y2. Similarly, this is x3. And this is y3. These distances are known. So what should be the perimeter of the square? We will extend the same logic here. So the perimeter of the square is of this entire shape is basically you add up all these perimeters. So I just initially add up all these perimeters. So if I add up all these perimeters, so what should be the perimeter? Let me write it here. So what should be all the perimeters? So first of all, I add up three terms. So they are 4m plus 4m plus 4m. So that is basically the perimeter of all these three squares. Now I will remove extra stuff, the things which I have basically counted again and again. So as we discussed, so this square, this is something whose boundary we have counted again and again. Even this is the part which we have counted again and again, isn't it? So we need to remove or erase the perimeter of these shapes. We, by simple geometry, we found out that what is the perimeter of this? What is the perimeter of this rectangle? It is nothing but 2 times. And we found out that this length is nothing but m minus x2. And this length is nothing but m minus y2. So this is 4m plus 4m plus 4m, the perimeter of all the three squares, minus 2 times m minus x2 plus m minus y2. So basically, what does that do? That basically removes, because since we have extra counted the perimeter of this rectangle, y2, because for this length we have this part and this part, and for this length we have this part and this part. Similarly, by the same logic, we also remove the perimeter of this square. What is the perimeter of this square? It's simply minus 2 times. Now this is m minus x3, because this is x3. This part is m minus x3. So we write a m minus 2 times m minus x3 plus m minus y3. Great enough. Anyone with any doubts? Is it clear? Okay. Anyone with any doubts, or is it clear? Okay, thanks. So that means if you are given a long array, if you are given a long array, say you are given all these values x1, y1, x2, y2, x3, y3, x4, y4, and suppose it goes till x and yn, So what should be the perimeter? So let me write what should be the answer. What is the answer we need to output? Basically, we need to output, first of all, we add up the perimeter of all the squares. That is what our logic is, right? You first of all add up the perimeter of all the squares. So basically add up the perimeter of all the squares. That is 4m plus 4m. And I add up n times. So I add up n times. So this is nothing but 4mn. And depending upon your implementation, you can implement it as you wish. You can add up 4m n times. You can write 4mn as your wish. And apart from that, what do you do? For all this part, like look at this diagram. Which values you erased? You erased m minus x2 and m minus y2. Remember what x1 and y1 are. X1 and y1 are these displacements, right? Like you started from the origin. This value was x1 and this value was y1. You never had to erase them, right? Because here there is no overlapping part. So we will not write any term for x1 and y1. So we simply write minus 2 times m minus x2 plus m minus y2. So that is basically, that removes duplicate region. Similarly, we write that we erase all the duplicate regions one by one. And it goes till ... till the nth region. Great. So is it clear how does the idea extends when you have a large number of coordinates given? Exactly, Amit. It's basically 4mn. That's the perimeter of all the squares minus all the overlapped areas. Because whenever you shift, there is some overlapping area or area which comes inside the region, but you have overcounted it in the perimeter. So let me show you the code. Maybe it gets a little bit more clear. So here is the code. I've taken n and m as input. After that, I have simply taken the coordinates x and y as input. Answer is something where I store the answer. So so I start from I from 0 to till n minus 1. There are multiple ways of implementing this. And as long as the logic is correct, all the implementations are perfectly fine. So whenever I'm processing I have basically added 4m. That basically adds the perimeter of that square. Then I calculate h and w. As I said, h is m minus y I plus 1. W is m minus x I plus 1. And then I reduce answer minus equals 2 times h plus w. Okay. Now see that since I has started from 0, I have written I plus 1 here. So basically, I am never subtracting x0 and y0. That is what our logic said, right? That the first coordinates which are given to you, x and y, they should not be added in your answer. Apart from that, since this loop runs n minus 1 times, and I need to add 4m n times to my answer, I do an extra answer plus equal to 4m, and then I finally print the answer. The logic of this code is same. There are multiple ways of implementing it. You could simply initialize answer as 4mn, and then you could simply decrease the answer using a for loop. Even that works fine. Okay, so is the logic clear? Everyone understood? Any doubts or need a dry run or something? Please tell. Okay, Anamika. Okay, great. So if it's clear for everyone, then we can start with the second problem. Okay, so let me read this problem. It says that you are given an undirected graph with n vertices labeled from 1 to n, and this graph encodes a hidden permutation p of size n. The graph is constructed as follows. For every pair of integers I less than j, an undirected edge is added between vertex pi and pj if and only if pi less than pj. Okay, note that the edge is not added between vertices I and j, but between the vertices of the respective elements. Refer to the notes section for better understanding. Your task is to reconstruct and output the permutation P. It can be proven that the permutation P can be uniquely determined. Okay, great. The value of n is given till 1000. That gives you a hint that an order n square code or a quadratic code would also work. So the constraints which are given usually give a hint on what approach can be found out. Okay, so let me first explain the problem statement. What does the problem statement say? The problem statement says that we will be given a graph. So I think it's usually not that common to see graphs as problem B of a div2 contest, but it's okay. Not any graph algorithm was required to actually solve the problem, so it's fine. So what was input? The input is given as a graph. So what is a graph? Graph is a set of vertices and edges. So it is said that you are given a graph with n vertices. It can be anything. And basically, you need to output a permutation. You need to output a permutation corresponding to this graph. Okay, so now how is the permutation created? So now the question explains, okay, first of all, for if someone does not know, though it is a very valid and standard concept, a permutation of say some size n, a permutation of size n is simply some reordering, of the array 1, 2, 3, n. So if you can reorder 1 till n and get something, then we call it a permutation. For example, let me ask you a few questions. So is 1, 2, 4, 3 and 1, 3, 5, 2, are these valid permutations? So this is the first one, this is the second one. Anyone? Are these valid permutations? Okay, great. The first one is a valid permutation, the second one is not. All of you are fine. Sriram, no, it is not a pure graph problem. Only the input is given as a graph. And even if you have not done graphs earlier, I would try to make you explain the solution. That's fine, right? Okay. Okay, so you are right. The first one is a permutation. This is a permutation of length 4. The second one is not a permutation because for if it is length 4, this is not a valid rearrangement of 1, 2, 3, 4. You can't rearrange 1, 2, 3, 4 to get the array 1, 3, 5, 2. First of all, because how does this 5 appear? Second, you can't have repetitive elements in a permutation. So like 1, 1, and 3, this is also not a valid permutation, right? Because you can't reorder 1, 2, 3 in any way to get 1, 1, 3. So I hope the definition of permutation is clear. Now, this is what the question says. So let me explain the question. The question says that they follow some procedure or some policy to take a permutation and then construct a graph. So suppose they take some permutation. Let me explain this using an example for concreteness. Let us take an example which they have given in the test case that may help. Okay, so let me take, so first of all, let me tell you the procedure. So they say that given some permutation, so suppose they have given some permutation 42135. Okay, just a second. Yes, okay. So suppose they have given you this permutation 42135. They said that they will follow some procedure to construct a graph from this permutation. What procedure? So they say they will do something like this. They will take a vertex. They will make a graph with 5 nodes. So this is the graph they are trying to make. So you have 5 nodes in this graph. 1, 2, 3, 4, and 5. How will they build the graph? First of all, the graph is undirected. That means the graph has edges have no directions. So they say you take the permutation 4. You look at all the right side elements and add an edge whenever you find a greater element. So look at 4. Look at all these right side elements. Do you find a larger element than 4? Yeah, you get 5, right? So add an edge between 4 and 5. So let me add an edge between 4 and 5. Fine. Now come here. Look at 2. How many elements you see larger than 2 here? You see 2 elements, 3 and 5, right? So add edge from 2 to 3 and 2 to 5. So add an edge from 2 to 3 and 2 to 5. Now come at 1 here. Come at 1 here. From 1, how many elements do you see larger than it? You see 3 and 5, right? So that means add an edge from 1 to 3 and 1 to 5. So let me do it. So take 1, add an edge from 1 till 1 to 3 and 1 to 5. Now come here. Come at 3. How many elements do you see on the right side which are greater than 3? There's only one element, right? 5. So add an edge between 3 and 5. Now come here at 5. How many elements do you see at the right of 5? There are no elements, right? So you do not need to add an edge. So this is the graph which you build. So it says that given a permutation, there is some process to build this edge, to build a graph. Now, what does the question says? The question says that they will not give you this permutation. They will not give you this permutation. They will give you this graph. So they will provide you with this graph and you need to output the permutation. So they will not give you this permutation 42135. What they will give you? They will give you this graph. I will explain how this graph is given. But suppose they give you this graph as input and then they ask you, okay, tell me what is the permutation from which this graph may be constructed. If you look at the second test case, this is what has happened. They have given this graph as input. If you look a bit carefully, you will realize if I have drawn right and have not made any mistakes, that these two graphs are same. Okay, let's check once. Yeah, so you can see that these two graphs are same. There is an edge between 4 and 5. So here it goes. There is an edge between 4 and 5. And then there are edges between 2 and 3, 2 and 5, 3 and 5. And then 1 is connected to 3 and 5. So both these graphs are same. And the question says that given this graph, so this graph is given as input and you have to print as output this array 42135. Okay. So is the question clear? Anyone with who has not understood the question properly? Understanding the question was important here. Okay, Advait. So I just, great. So since the question is clear, let us try to understand the solution. Okay, so first of all, what did I say? I said that they will give me a graph as input. Great. So how can a graph be given as input? Any idea? I'm discussing this because this is a diff to B. So there are people who would not, maybe who are not very affluent with graphs at this level. So any idea how is graphs given as input? Okay, great. So whenever you see a graph as a problem, basically graphs are always given as an adjacency list or an adjacency matrix as input. So here we were given an adjacency matrix. Okay, so we were given an adjacency matrix. So what is an adjacency matrix? So let us take this graph for example. Let me draw this graph again here for simplicity, so that we do not need to look. So here we had 5 nodes. So we had 1, 2, 3, we had a 4, and then we had a 5 here. And the edges looked something like this. So there is a 2, there is an edge between 2, 3, 2, 5, 3, 5, 4. And from 1, there were 2 edges, a 1 to 5 and 1 to 3. Okay, if I've mistaken, let me check once. Okay, looks correct. So suppose if the question setter wants to give this graph as input, let me show you how will he give us. He will give us in the form of an n cross n matrix. So he will try to give us this as the form of an n cross n matrix. How will he give us? In the first row of the matrix, he will look at 1. So let me draw the matrix. So basically this matrix has 5 rows, 1, 2, 3, 4, 5. Okay. And it has also 5 columns. So here comes, just a second. Just a second, I'm facing some issue. Great. So here are the rows 1, 2, 3, 4, 5, and here comes the columns 1, 2, 3, 4, 5. Okay. Now you look at 1 and you find out its neighbors. What are the neighbors of 1? 3 and 5. Okay. So at 3 and 5, you write a 1. So basically at the first row, you look at all the neighbors of 1. So here are the neighbors. At 3 and 5, you mark a 1 because 3 and 5 are the neighbors of 1. And for all other things, you mark a 0. Now look at 2. What are the neighbors of 2? There are 2 neighbors of 2, 3 and 5. So you mark 3 and 5 as 1 and keep rest all of them as 0. You look at 3. What are the neighbors of 3? There are 1 is a neighbor, 2 is a neighbor, 5 is a neighbor. So you mark 1, 2 and 5 as 1 and keep all others as zeros. Now look at 4. 4 is only neighbor 5. So in the fourth row, mark 5 as 1 and keep all other things as 0. Now look at the fifth row. It has 1, 2, 3 and 4 as neighbors, right? So you mark 1, 2, 3 and 4 as 1 and then you mark 5 as 0. So this is what is called an adjacency matrix. The best part about an adjacency matrix is that if you want to check, okay, do I have an edge between 2 and 5? Then you just go to the second row, look at the fifth entry and see if it is 0 or 1. If it is 1, then yeah, you have an edge between 2 and 5. Now suppose you want to check that whether there is an edge between 2 or 4 or not. So just go to the second row, look at the fourth column. So it's 0. It's 0 means that there is no edge between 2 and 5 or 2 and 4. So is the input format clear? Like if this graph is required to be given as input, then we will be given this adjacency matrix as input. Even if you look at the CF problem and look at this test case, this test case matches exactly with what we have written. So that means that they have basically given this graph as input. Okay, so is the input format clear? I think most of you were accustomed with adjacency matrix. Okay, great. So now let's discuss the problem. So first of all, forget about code and everything. Let us just look at this graph. So let us just look at this graph. Let me draw this graph somewhere here. So we had 5 nodes, 1, 2, 3, and then we have a 4 and a 5. Great. And here there are the edges. So there is an edge between 4 and 5, 2 and 5, 2 and 3, 3 and 5, 1 and 5, and 1 and 3. Okay. And this is given as an adjacency matrix to us. What we need to output 5 integers. Basically, we need to output a permutation. So we need to output 5 integers, which must be some reordering of 1, 2, 3, 4, 5. That is clear. How can we do this? So what I thought initially is that the most interesting position is 1, right? Why is 1 the most interesting? Because remember our algorithm to convert from a permutation to a graph. If I had 1 somewhere here, then all positions which are to the right of 1, they has to be greater than 1 because 1 is the minimum element. So all positions which are righter to 1 must have an edge between 1 and itself. So that means you can simply look at 1 and look at what all neighbors 1 had, and you can simply understand that, okay, which part should lie to the right of 1 and which part should lie to the left of 1. For example, just looking at this graph, I can understand that, okay, 1 should be somewhere midway in the array, in the permutation. Now 1 has 2 neighbors, 3 and 5. So that means 3 and 5 should come at this part of the array. So there must be 2 elements in this part of the array to the right side of 1, and it should be either 3 or 5. Similarly, there are 2 nodes 2 and 4 which do not have 1 as neighbor. So that means 2 and 4 should come at left part of the array. Is it clear? Why do I claim that 2 and 4 has to always come at the left side of 1 and not at the right side? Okay, great. So what does that mean? That means that the negative element, that the smallest element which I have in the array is interesting because it helps us to bifurcate the array into 2 positions. So since I get the position of 1, I know that, okay, 2 and 4 has to lie somewhere here, and 3 and 5 has to lie somewhere here. Great. Now look at this left portion. So let me do this. So basically we had 5. We had a 1 here, and then we know that 2 and 4 must come at this part, 3 and 5 must come at this part. Great. Now look at this part. I am interested about this part of the problem now. I know that there are 2 possible elements, 2 and 4. Always look at the minimum element. The minimum element is interesting. So look at 2. So when you look at 2, is 2 a neighbor of 4? No, na? So 2 is not a neighbor of 4. That means here 2 must have come to the right side of 4, right? So here 2 must have came here. Why so? Because if 2 would have come here and then 4 would have come, then there would have been edge between 2 and 4 in the graph, which is not the case. So that means 2 must have come here and the remaining position is 4, which must have come here. Isn't it? Similarly, by the exact same logic, if you look at 3 and 5, take the minimum element. The minimum element is always interesting. Look at 3. Is there an edge between 3 and 5? Yes, there is an edge between 3 and 5. That means, since there is an edge between 3 and 5, 3 must have came to the left side of 5, right? 3 must have came to the left side of 5. That is why there is an edge between 3 and 5. Because if 5 would have come before 3, then if 5 would have come before, just a second. Yeah, if 5 would have come before 3, then at the right of 3, it would have not got any 5. And then in the graph, there would have been no edge between 3 and 5. But since in the graph, I can see an edge between 3 and 5, that means that 3 must have came in the left side of the array. Okay. So is the logic clear? Like, how did we get to 42135? Yeah, great. One thing which you can do is that you can continuously try finding the minimum element of this range, or you can just iterate over 1 to n. So let me explain. So there are multiple ways to solve this. Like one way is that you take this portion, and in this portion you find the minimum element 2, and then you try to find the position of 2. Now you come to this portion, then you find the minimum element 3, and then try to find the position of 3. This is one thing you can do. Or you can just or what you can do is, or what I have done is, simply run a loop. Simply run a loop for I equal to 0 to n minus 1. And, or we can say for I equal to, just a second. Yeah, simply run a loop for I equal to 1 to n, and then try to find where I can be placed in the array. I will try to explain it using a larger example. So to understand what has actually happened. So suppose you have been given a large graph. Suppose n is quite large. So there are a lot of positions. So suppose there are a lot of positions. So what will you do? You first look at 1. So what is the value of n I have taken here? I've taken n as 4, 8, 12, and 13. So I have taken n as 13 and can be anything. So suppose n is 13. I initially look at the graph. Okay, instead of using such a weird test case, okay, we do not have some good test case here also. That's fine. Yeah, so the idea is that suppose the value of n is 13. What do? I basically take the graph and try to find the position of 1. So what will I do? So I will try to find the position of 1 first. So suppose 1 comes here. What do I mean by 1 comes here? That means I know all the neighbors of 1, all the nodes which have edge with 1, they must come to the right side of 1. And all the nodes which do not have edge with 1, they must come to the left side of 1, right? So that means you always get, when you start with 1, you get the position of 1, and then you also bifurcate or break down the problem into 2 different subproblems, which are one to the left side of 1 and one to the right side of 1, isn't it? So suppose you break this, and suppose you break this into a bunch of values. So suppose you get 3, 5, 8, 10, and 12 here. And all the remaining values, that is 2, 4, 6, 7, 9, 11, and 13 here. Okay, so what does that mean? That means that all these nodes 3, 5, 8, 10, and 12 were actually neighbors of 1 in the input graph, and all these nodes were not neighbors of 1 in the input graph. Great. Now try to find out where can I place 2. So I've placed 1. Where can I place 2? So if you want to place 2, what do you basically do? You basically look at this part of the array. So you just look at this bunch of elements and try to find out how many nodes have edges with 2 in this bunch of elements. So suppose 2 has edges with 6, 7, and 9. So suppose 2 has edges with 6, 7, and 9. What does that mean? That means that 6, 7, and 9 would have come to the right side of 2, and 4, 11, 13 would have came to the left side of 2. So where should 2 be placed? 2 should be placed in such a position such that you get 3 places to fill 6, 7, and 9, 9 to the right side. So that means 2 must be placed here. So now look at how the problem has changed. So initially we had this bunch of elements. Now you have got 2, right? So if you have got 2, so basically this is where 2 is. Now the problem has broken down to a bunch of numbers. You have 6, 7, 9 here. So you have 6, 7, 9 here in this part. And in this part, what are the values which are possible? You can put a 4 or a 11 or a 13. So that means at every part, at every time, you are basically finding the position, and then you are breaking this stuff into smaller portions of the problem. Look at this part. Suppose you are now analyzing 3, and you saw that, okay, 3 has an edge with 5 and no others. That means you know that 3 has to be placed. Where does 3 need to be placed? 3 needs to be placed here, right? So that there is only one position remaining where 5 can be. So 3 needs to be placed here. So that again breaks down the problem into two subparts. So since 3 is placed there, you know that, okay, there is this region where 5 can be placed. And then there is this region where 8, 10, and 12 can be placed. Okay, so I am trying to explain you how the problem is getting divided and broken into smaller and smaller parts. Basically, what you are doing is you are iterating over 1 to n, and you are trying to find the position of every element by looking at the graph, which one are neighbors and which one are not. So now let me show one more example. Suppose you are here at 4. And now you analyze the graph, how many edges are there between 4 and 11 and 4 and 13. So you see that, okay, suppose there are no edges, like 11 and 13 both are not neighbors of 4. That means you know where should 4 be placed. Okay, let me ask this one. Anyone in the chat, where should 4 be placed?
Adjacent of 2.
Correct. 4 has to be placed at adjacent of 2. Why? Because there are no neighbors of 11 and 13 both are not neighbors of 4. That means 11 and 13 both has to be the left side of 4. That means 4 needs to be placed here. So again, the problem breaks down into a smaller subproblem. So now you don't have this entire region. You have this region, 11 and where you know 11 and 13 is there. So if you can compute, or you can try run this algorithm every time, so finally we'll get the position of all elements. What remains as a challenge to us is analyzing or understanding how in our code we can try or keep track which element comes in which range. Like 6 can lie only in this range, 7 can lie only in this range, 13 can lie only in this range. So this is something which we need to keep track of in our code. So any idea how can this be done? So basically, like, look at how the algorithm started. You put one in some part of the array, and then you broke the array into multiple parts, right? But then you broke the array into multiple parts. So that is something which looks good when you say it on paper. But how can you implement it in your code? Okay. So this is an idea which will come handy, or which will come useful to you in many problems. Like in many problem where you see a pattern that, okay, the problem is breaking down into smaller sub problems, and every element 6 can actually be in some range of the array. So it can be from some range L to some value R. So it has to always exist among this range, right? So does that not give you a hint that, okay, when I'm trying to implement this, let me try to maintain two arrays L and R. So let me try to maintain two arrays L and R of size n. Okay. So what does L and R mean? So basically Li means what is the leftmost position where I can be at? What is the leftmost position? What is the leftmost position I is allowed to be at?
0.
Excuse me, anything? Okay. So, and similarly, Ri is nothing but the rightmost position I is allowed to be at. So yeah, as some of you were saying, we initialize L of I as 0 and R of I as n minus 1 for all the elements. Is that clear? Why do we do so? We initialize Li as 0 and Ri as n minus 1 for all elements. So basically, when you have not started the algorithm, all the elements from 0 to n minus 1, they can, or 1 to n, they can be anywhere in the array from index 0 to n minus 1. That is clear. Now what do you do? Now here is where things become interesting. So suppose you now analyze 1. When you analyze 1, you broke down the problem into two arrays, right? So when you broke down the problem into two arrays, you get a bunch of numbers which can be at left you get a bunch of numbers which can be at right. So let me call this index. So let me call this index as position, POS. So what do you think? What changes you need to make at L and R values at the left bunch of elements? So suppose there were some left bunch of elements which I initially wrote here, right? So there were some 11, 13, 4, 2, 6, 7, 9, right? So what changes you should make in your L and R values of these all elements in order to ensure that, okay, this works fine? Any idea? At the left side of 1, what should you do? Correct. L is same and R becomes pos minus 1. Okay, L is same and R becomes pos minus 1. So L remains same, R becomes pos minus 1. Great enough. Okay, and what changes to the right part of the array? Anyone? What? Great, pos plus 1 to R. So at the right part for this bunch of elements, what changes we need to make at L and R? We simply keep L as pos plus 1 and we keep R as same. That's fine. So this is actually an idea or something which will come very helpful whenever you need to keep track that, okay, some element I will always lie between in some region of the array. Then you always try to maintain two arrays L and R, where Li and Ri stores where the element I can be at, like what is the maximum and minimum position I can be at. Okay, great. So now let me ask you a question. How can you check that two elements lie in the same bunch? Like that is something you need to check, right? Like for example, now after this, you are trying to check where can you lie 6 at. So whenever you need to check where 6 can be at, you basically need to iterate over all elements from 1 to n. Check how many people lie in this bunch. So you will get only two elements, 7 and 9. And then you need to check, okay, how many of these are neighbors of 6 and how many are not neighbors of 6. So any idea how can you check that whether this element lies in the same bag as 6 or not? Correct. Okay. So Mehak said, which is actually correct, that if you need to check that, okay, 7 lies in the same bag as 6 or not, you just basically check that, okay, is L6 equal to L7 and R6 equal to R7 or not? If both these conditions satisfy, that means it is the same range of L and R where 6 and 7 actually sit. And then you can just say, okay, L6, okay, that they lie in the same bunch. You can actually check the neighboring conditions. Great. Okay. So now a final question. Suppose now I found out the position of, so I found out the position of 4, right? So what changes do I need to make at the L and R values of 4? Any idea? Suppose I found out the position of some element, then what changes should I make to the L and R of that element? I have to make some changes at the L and R of that element, right, to keep it as valid. Great. L and R has to be made equal, right? So if you found out that, okay, 4 needs to sit at some position pos, then what do? You just simply said, okay, L4 is simply equal to R4 and that is equal to 4 because and that is equal to pos. So now you basically know that 4 has to sit at this same position pos. Okay, so that completes the implementation. So I think so let me share the code with you once. Let me explain the code and then we will try to understand if there are any doubts. Okay, so I have taken n as input, that is the size of the permutation or the size of the graph. And then we take the adjacency list as input. The adjacency list is given as n strings. So we made a vector of string of size n and we took all the strings as input. Great. Answer is my vector where I will print what is the final answer. So you can see that finally I've just printed answer. Great. I make two arrays L and R. I initialize the L array with 0. I initialize the R array with n minus 1. So that basically shows that, okay, initially all the values can be anywhere from L to R, right? Now, here this is interesting. What do I do here? I just basically iterate over all nodes from j equal to 0 to j equal to n. So this is a for loop which runs from I equal to 0 to I till I equal to n. So at the ith iteration, I will be processing node I. So basically at the ith iteration, I will try to find out where can I place I at, right? Okay. So basically it is this loop. So basically initially, what do I do? Initially, I find out what is the position of 1. Then I try to find out what is the position of 2. Then I try to find out what is the position of 3. Then I try to find out what is the position of 4. So it is something like this. So I loops over all the elements and we are trying to find the position of I at index I. Great. So how can I find the position? I loop over all other values j from 0 to n. I check that is Lj equal to Li and Rj equal to Ri. If Lj is equal to Li and Rj is equal to Ri at the same time, that means that means I and j both are at the same bag. And if that happens, then I check that okay, is adjacency ij is 1. That means is I and j is there is an edge between I and j. If that happens, then we increase the value of count. Okay. So what does CNT store? So that means at some position, so at somewhere midway in the code, where there is a large array, and then you are analyzing some portion, between L and R. And suppose you are trying to check, okay, where I is, and then you looked at all the neighbors J of I, which are in the same bag, and you found out that, okay, there are CNT such neighbors where there is an edge between I and J in the same bag. Okay, so where should I place I? Anyone? Where
R
should I?
minus CN.
Correct. We should store it R minus CNT, right? Always try to look at edge cases, like what if CNT is 0? If CNT is 0, that means all values are to the left of I. So that means I need to store I at R position. If CNT is 1, I need to store it at R minus 1 so that I leave one extra space for that extra element which will come to the right. So that is what I've done. If you look at the code, so I've kept the position as Ri minus CNT and I've marked answer pos as I plus 1. So basically, I am populating this answer array, which I will print at the end. Why I plus 1? Because I goes to 0 to n minus 1. So I was using 0 based indexing in my code. But when I need to print the output, I need to use 1 based indexing. So just a plus 1 for that. Apart from that, I have found the answer, but we are not done yet. We need to update all the L and R values. Whenever you are using a data structure and you are trying to leverage the advantage of the data structure at some part of the code, you also need to ensure that the data structure remains valid for the further iterations to come. So how do I do that? So again, I look at all those elements which are in the same branch, and for all values I not equal to j, so all different bags, I look at, okay, is there is an edge between I and j? If there is no edge, that means it must come to the left side of I. So in that case, we keep the L value same, we do not touch it, and we mark R as pos minus 1. If we see that, okay, adjacency of ij is 1, that means there is an edge between I and j, so we keep the R value same and we mark Lj as pos plus 1. Finally, after this is done, I know that I've set I at position pos, so I mark both L and R at value pos. And finally, we print the answer. Okay, great. Anyone with any doubts, please. Is it clear? Anything confusing? Yeah, Anand, exactly. That's like, it is very similar to what I said. Okay, can someone
Can
please
we do
confirm?
this in O1 space?
Can we do this in O1 space? Okay. See, like, first of all, yeah, first of all, this is something which is given as input, right? So this matrix is given to you as input. So you have to take it. So just reading the input, like you can't just read the string and throw away the inputs, right? Then you will not be able to solve the problem. So this is something which you need to take as input. So this vector string adjacency n, this you have to always make in any solution you write. This is something vi answer of n. This is something which you need to print as output, right? So since you need to print as output, this is also a necessary part of the code. So this is something which you have to make. Apart from that, this is the auxiliary space which we have used. We have marked, we have taken L and R values, which, so we have taken L and R values, which basically stores the coordinates, leftmost and rightmost coordinate. So the auxiliary space for the code is order n, I agree. I am not very sure if we can do it in order 1. Maybe we can, but I have to think about it once. But in problems where the value of n is so small, it is just 1000, taking order n auxiliary space won't hurt at all, because your time complexity is itself order n square, right? So if the time complexity is order n square, so that means even if you take order n square space, like this, the size of this adjacency matrix is itself order n square. So it is much larger than this L and R arrays, right? So even if you do not make these L and R arrays, the size, the memory which the computer program takes to run would not asymptotically change. So probably it does not make much of a difference. But yeah, I'm not sure if you can do it in order 1 auxiliary space. Okay, Anand says an example where we can do it. Okay, I need to check once. If you can do it, that's great.
Yeah, I too did that way, something similar to like insertion sort. But
Okay, great then. Then probably it
yes.
can be done. I've not thought of it during the contest. I have to think about it once, but but since you all did it, then probably it's great. It can be done then. Okay, but what I explained to you, like this is something, I think even this is something which you can like try applying in lot of problems. Like in there you will see lot of problems where L and R values, where you would need to actually keep track of how which index comes in which range. So this is an approach which comes very pretty handy, like storing L and R values. So that is the reason why this always comes very quickly in my mind when I try to solve these type of problems. Yet, yeah, order 1 space is actually good enough to run, and even this works. Okay, so Amit is asking to repeat the code approach again. So Amit, I will explain what I've done in short. Basically, what I did is I tried to iterate over 1 till n, and I always try to find the position of the ith element in index I. Why did I looped it in increasing order from 1 to n? Because I know that I can actually take index I and try to find out and I can find its position by just looking at the graph. So if I look at the graph and if I look at all of its neighbors, all the neighbors which I have of I, they will always be in the right side of the array, and all other elements will be on the left side of the array. So that by that way I can find the position, and then I can actually break the problem into smaller subparts. Okay, great. So can we start with the third problem? Anyone with any more doubts? Okay, so let's start with the next problem. Okay, so this is the problem. It says that for an integer sequence A as A1 till An, we define f of A as the length of the longest subsequence of A, that is a palindrome. Let G of A represents the number of subsequences of length f of A that are palindromes. In other words, G of A counts the number of palindromic subsequences in A that have the maximum length. Given an integer n, your task is to find any sequence A of n integers that satisfies the following conditions. First of all, AI should always lie between 1 till n, and G of A should be greater than n. Okay. The value of n can be from 6 to 100. That is given. Okay. So let me explain the problem statement first. So the question is simple. The input is simply an integer. They will give n as input, nothing else. And they first define two functions. So the first function they define is f of a, which they say is the length of the longest palindromic subsequence. Length of the longest palindromic subsequence. There are two terms which are important here. One is palindromic and the other is subsequence. So I think you all know what a palindrome is. So palindrome is something which reads the same when you read it from back to front. So for example, just for the sake of example, say 1 2 1, that is a valid palindrome, or 1 3 3 4 3 3 1, that is also a valid palindrome. But 1 5 1 and 1, this is not a valid palindrome. Why? Because here, if you read 1 to 1 forward or 1 to 1 backward, they all read the same, right? Even with this array, it reads the same. But here, if you read from front to back, it is 1511. If you read from back to front, it is 1151. So it reads different when read from back to front. So this is not a palindrome, but these two are. Apart from that, one more term which was used in the problem statement is subsequence. So what do you mean by subsequence of an array? So suppose you have an array 1, 3, 5, 10, 26. So basically, you can remove any elements in the array you want. So you suppose you remove some elements, and what remaining array you get is basically a subsequence. So suppose I wish to remove this 5 and this 26. So I get so what do I get? I get 1, 3, and 10, right? So that is a valid subsequence. Similarly, 3 and 26 is a valid subsequence. Okay. Now let me ask you, is 5, 10 a valid subsequence? Is 1, 10, 5 a valid subsequence? Anyone?
1 10 5 isn't, because order is not preserved.
Correct. 5 10 is a valid subsequence because you can remove 1, 3, and 26 to get 5 10. But 1 10 5 is not a valid subsequence because the order of the elements is not preserved. You will not get 1 10 and 5 in the exact same order in the array as well, anywhere. And you can't remove elements from the array to get the elements in the exact same order. Like even if you remove 3 and 26, you get 1 5 10 and not 1 10 5. So this is not a valid subsequence, but this is. So these are the two terms which are very common, palindrome and subsequence. You will see multiple times in lots of problems in Codeforces or LeetCode and everywhere. So these are standard terms which you should explain, which you should understand irrespective of of any problem statement. So it is clear. Anyone who has problems with these basic definitions? Okay, no. So let's try to understand what does f of a mean. So the problem says f of a is the length of the longest palindromic subsequence, right? So you take any array. Suppose I take 1, 2, 3, 2, 3, and 1. So what is the length of the longest palindromic subsequence you can see? So look at all the subsequences and look at subsequences which are palindromes. So 1, 3, 1, this is a valid palindromic subsequence, right? So if you can look at 1, 3, 1. This is a valid palindromic subsequence. Similarly, you can look at 1, 2, 2, 1. That is also a valid palindromic subsequence. Similarly, I see 1, 2, 3, 2, 1. That is also a valid palindromic subsequence. So look at all palindromic subsequences of this array and try to find out the longest palindromic subsequence. So the longest palindromic subsequence in this array is 1, 2, 3, 2, 1. I do not find the palindromic sequence which is larger than this because this is of length 5. The only way to get a palindromic subsequence which is larger than 6, larger than 5, is to have a subsequence of length 6, but that would mean the entire array, which is itself not a palindrome. So the value of f of a in this case is 5. So whenever you are given any subsequence, how to find the value of f of a? Look at all subsequences which are palindromes and return the longest length basically. So that would basically return what is the length of the longest palindromic subsequence. Now the question also mentions one more function g of a, and it basically says that how many palindromic subsequences are there. How many palindromic subsequences how many palindromic subsequences of length f of a. So basically, how many longest palindromic subsequences are there? So for example, let us take some test case and try to understand 1, 1, 2, 3, 1, 2. This looks good. So let's take this example 1, 1, 2, 3, 1, 2. Can someone tell me what is the value of f of a for this? Suppose this is a, then what is the value of f of a
3.
for this? Correct, 3. Because I can see a palindromic subsequence of say 1, 1, 1, but I cannot see a larger palindromic subsequence. You can never find a palindromic subsequence of size larger than 3 in this case. So basically, the value of f of a is 3. Now, what is the value of g of a? The value of g of a is nothing but the number of unique palindromic subsequences which you can find here. So look here. They have explained this question nicely. So you have this array 1, 1, 2, 3, 1, 2. The value of f of a is given 3. And there are 7 ways to choose a subsequence of length 3. So basically, the value of g of a is how many number of ways you can find a subsequence which is palindromic and has length 3, which is equal to f of a. So look here there are 7 subsequences. You can choose the a1, a2, a5, that is the first, second, and the fifth element. You can choose the first, third, and the fifth element, and so on. So that is the reason the value of g of a is greater than 7. And the question asks to print any array A where the array values are from 1 to n, it cannot exceed n, and the value of g of a has to be greater than n. So that is what the question asks. So is the question clear? Anyone with any problem in the problem statement itself? Okay. So if the problem statement is clear, let us try to understand the problem. So when I was given this problem, I thought of first getting a bit familiar with the functions f and g. So what if I have this array? Like suppose I have all ones. Suppose array A is all ones. This is of length n, okay? So can someone tell me what is the value of f of a and what is the value of g of a? Anyone?
N and 1.
Correct. F of a is n. So what is the length of the longest palindromic subsequence? You simply take all these area, all these length, all these elements, right? So it is a 1. And the value of g of a, that is 1, right? Because there is only one subsequence of length n, that is the entire array itself. So you can't have you can't have more than one subsequences. So this is kind of useless. Like because we need to print some array A where the value of g of is greater than n. So even n does not work. So here it is 1. So it is kind of useless. But then this type of, I will always recommend you that whenever you get some new function, try to get accustomed with the definitions by looking at test cases like this. So let us have one more test case. What if we have all distinct elements, say 1 till n? Any idea what is f of a and what is g of a?
1 and n.
Okay, great. So since we have all distinct elements, if you need to make a palindrome, you can never make a palindrome of size 2. Because even if you take 2 elements of size 2, these values will be definitely different and then it will not become a palindrome. So the largest palindrome which you can get is of length 1. And how many palindromes you can get of length 1? You choose any distinct element. So you have n elements, choose any one of them. So you get the value n here. So that means this was a case where we were close enough. We need to actually print the value g of a greater than n, but here we are getting n. So we need to do something different. So actually, in these type of questions, it is a lot observation based, and you have to try to understand what type of structure in the problem can actually help you get a lot of palindromic subsequences. So so something like that. So an idea which I had is that what if I had some values one, suppose I need to make a palindrome, right? So suppose I had say 2 ones in the array, and then I have a lot of distinct elements. So I have a lot of distinct elements here. If that is the case, then maybe I can actually have lots of palindromic subsequences, right? Maybe the value of g of a can exceed n. Like that was my initial idea. So let us try this. So suppose I have a 1 here, and then I have a 1 here. And suppose I fill this entire thing with distinct values. So I give 2, 3, 4, and it goes till n minus 1. And then we have 1 here. So any idea what is the value of g of a and what is the value of f of a?
3 and n minus 2.
N minus 2. Okay. So the value of f of a is 3. Okay. Yeah, great. The value of f of a is 3. And the value of g of a is n minus 2. Why the value of f of a is 3? Because you can make a palindromic subsequence of length 3. You can choose these two ones and then any distinct element in the between. And since there are n minus 2 distinct elements, so the value of g of a is n minus 2. So this solution did not work. Probably it did not work because we had just one way of choosing ones, right? So we had just one way of choosing ones, and then we had to take distinct elements. So this was something like we were getting some benefit, but we got the benefit only once, and that is the reason it did not exceed n. So my next idea is, why not do something like this? Why not have 1, then 2, then 3, and let me have till something, some say we went till n minus 2 here, right? N minus 1 here, right? So let me go till n minus 2, then let me have a 1, and then let me again have a 2. So why I did this? First of all, understand the psychology behind doing this. I did this so that I can get the benefit for these two pair of ones, and I can also get the benefit for these two ones. So that was my initial psychology. So anyone who can say what is the value of f, what is the value of f a here and g of a here? Anyone? What is the length of the longest subsequence you can get? You have to take a 1. Suppose I start with 1. If I
2n
start
minus
with
3.
just a second, what?
3, sir.
Okay, so you say that f of a is 3. Great. So f of a looks 3 because the longest palindrome which I can get is 1. I can get 1 from these two ends, and then some distinct element in between. Okay, that's fine. So f of a is 3. So what is the value of g of a?
2n minus 5.
2n minus 5. The value of, so it is basically for this one, I can have these n minus 3 values, right? I can pick any one of them. And for I can pick all these two and I can still have n minus 3 values, right? So it should be something like 2 times n minus 3. Is it?
Yes, sir.
Great. So actually, so look at this. You have got something very interesting. You have got 2n minus 6. And you can see that for large values of n, so if the value of n is 100, if the value of n is 100, then what is this value? This is 194, right? This already exceeds 100. So that means just by doing this, just by taking the advantage twice, we can actually make this value larger than n. That sounds fun. What I have done is, and all these solutions pretty much have the same idea. What I have done is, I have written till 1, 2, 3, till say n by 2. And again, I have again repeated the same thing. 1, 2, again it goes till n by 2. So any idea what is the value of f of a and g of a here? All of these have the same psychology. Like we are trying to leverage the benefit of coupling these two integers and taking one distinct element in between multiple times. So I take this to 1 and take one distinct element in between. I can take this 2 and this 2, and I can take one in distinct element from between. So what is the value of f of a here? By the same logic,
3.
f of a remains 3, right? Nothing new. We take two distinct elements and then we just simply take two repetitive elements and just one duplicate element in between. And what is the value of g of a here?
N squared divided by 4 minus n by 2.
Okay, so let me write it simply. Basically, we can choose with this duplicate element, we have n by 2 choices. So I write an n by 2. And whenever I choose a duplicate element, so suppose I've chosen this one, and suppose I've chosen this one. So then I have n by 2 minus 1 choices here to choose a distinct element in between them. So basically n by 2 times n by 2 minus 1, which is n times n minus 2 by 4. I think you also said the same, and that's all right. So these are solutions which are pretty similar, have the same idea, and work the same way. So now we want, so I can always print this answer where g of a is basically n into n minus 2 by 4. But I want this value to be greater than n, right? So I want n times n by n minus 2 by 4 should be greater than n. This n gets cancelled. So this simply means that I want n to be, so that simply means that I want n to be greater than 6. Actually, if you consider that we have taken this for or even elements, even for now, if you have odd element, you can put one more extra element here, and that would actually not count anywhere to the value of f of a and g of a. So even for n equal to 7, this will give a problem. So like look at n equal, let me show you the n equal to 6 case and n equal to 7 case. Like if n equal to 6, as per my logic, we print this array 1, 2, 3, 1, 2, 3, right? So here, as we said, the value of f of a is 3 and the value of g of a is 6. Why so? Because what is the length of the longest palindromic subsequence? It is simply 1, 2, and then again a 1. You can't even never make a palindromic subsequence of length 4 here. And how many can you make? You can make 6. What are those 6? You basically pick two same elements and any of the two distinct elements from between. So these six subsequences would look something like this. You pick a 1 and then you have a 2 somewhere. Or you pick a 1 and you have a 3 in between. Or you pick a 2 and then you have 3 in between or a 1 in between. Similarly, for 3, you can have a 1 in between or a 2 in between. So you get 6 values. Even if you have 7 as the test case, then using my test case, you write a 1, 2, 3, 1, 2, 3, and suppose you write an extra 4 here. Then also the value of g of a remains 6. But for test cases where n is greater than 7, so for any test case, n suppose is greater than equal to 8. If n is greater than equal to 8, then I already have a solution where the value of g of a is n into n minus 2 by 4, right? And that will be simply, and that would be greater than n, right? Because we know that in order to, for this expression to exceed the value of n, I want the value of n greater than 7. So that means when n is greater than equal to 8, my logic works. Great. So what does the code says? The code, what will I do? I will check is n greater than equal to 8. If n is greater than equal to 8, I can simply print 1, 2, 3, dot, dot, dot till n by 2. And then again 1, 2, 3. This same thing goes on. This works if n is greater than equal to 8. Any problem? Anything where it's not clear?
Can you please explain this part? Like, what is the issue with n greater than 7?
Okay, so I said, I actually showed you a test case, right? So I said that what will I do? So suppose this is my algorithm. My algorithm takes n and then it simply prints 1, 2, 3 till n by 2. And then it again starts from 1 and it prints 1 till how many, till the end. It prints till the end. So we need to print n integers. So it has printed n by 2 integers, then it prints the remaining integers, again the increasing order in the same way. So what is the value of f of a and g of a here? So that was my question. What is the value of f of a here? What is the value of g of a here? I said that the value of f of a here is 3 because the largest palindromic subsequence you can get here is 3. How? You simply take two same elements, say 1 and 1, and pick any duplicate element in between. So you get f of a is 3. You can never get a larger palindromic subsequence. How many subsequences you can make? That's interesting. So whenever you need to make a subsequence, first of all, you need to choose the first so since you have to make a palindromic subsequences of subsequence of length 3, it has to be of this format ABA, right? So you have to choose A. How can you choose A? There are n by 2 ways of choosing A. Either you choose this one and this one combined, or you choose this 2 and this 2, or you choose this 3 and this 3. So, or you can choose this n by 2 and then this n by 2. So there are n by 2 ways of choosing A. Okay. Now suppose you have chosen A. So suppose you have chosen A. So suppose you have chosen this as A. So this is 1 and this is 1. How many remaining values you have to choose B? So there are n by 2 minus 1 choices to choose B, right? So here there are n by 2 minus 1 choices to choose B. So the value of g of A is n times n minus 2 by 4. Okay. But the question does not tell us to choose a value so what does the question tell? The question tells that you print some array where the value of g of A is greater than n. So that means in order for my solution to work, this value n into n minus 2 by 4 should be greater than n, right? So n into n minus 2 by 4 has to be greater than n in order for my solution to work. So I say let's solve this inequality. What do I get? I get that n must be greater than 6. So that means if n is equal to 6 or n is equal to 7, then my solution fails. Then my solution fails. It does not work. But for any value of n greater than equal to 8, for any value of n greater than equal to 8, my solution passes. Why does my solution passes? Because then this quadratic function n into n minus 2 by 4 will exceed n and then my solution will pass. Like look at the values of n equal to 8. So suppose n is equal to 8. If n is equal to 8, what is n into n minus 2 by 4? It is simply 8 into 6 by 4. What is 8 into 6 by 4? That is 12. So that means my value of g of A, 12 is greater than 8. And this will continue for all values of n greater than equal to 8. So that means whenever n is greater than equal to 8, then my solution works perfectly fine. The only problem comes when n is equal to 6 or n equal to 7. Like these are the situations where my code will fail. So is it clear? Did you understand?
Yes, thank you.
Okay, Anamika asks that why does not work for n equal to 7? So actually, Anamika, if you look at this expression is not perfectly correct. This expression works. Why? Because here during this expression, I have chosen this n by 2 here, right? So n by 2 makes sense only when n is even. So what does my solution say? My solution say that if n is even, then you simply print 1, 2 till n by 2. And then you again print till 1 till n by 2. And what do you do when n is odd? If n is odd, then you print 1 till n by 2. Here by n by 2, I mean the floor value. And then again you print 1 till n by 2. And then you again print this extra n by 2 plus 1. So this is for even cases, this is for odd cases. For example, if n is 6, you just print 1, 2, 3, 1, 2, 3. If n is odd, you print 1, 2, 3, 1, 2, 3, 4. So that means, now look at this, that when you print this extra element during the odd case, so this element never contributes in the value of g of A. You can never use this element to make a palindromic subsequence of length 3. Why? Because you have only one occurrence of this element here, right? You have only one occurrence of 4. 4 does not comes here. So that means whatever value of g of A you get at 6, that same value of g of A you will get at 7. So that means if it does not work for 6, it will also not work for 7. So this expression is kind of misleading because this I have computed only to get a rough estimate, and this actually works only for even values of n. And I know that, okay, for n equal to 6, if it does not work, for n equal to 7 also it will not work, because the value of g of a will not change as per my algorithm in 6 or 7. But now I know that, okay, this works for n equal to 8. And since it works for n equal to 8, it will work for all larger values of n. Like for n equal to 8, the value came 12, right? That means for 9 also the value will come 12. For 10 you can again look at this formula. It will come 10 into 8 by 4. So that will be 20. So it will be quite larger than 10 and it will work. So is that clear? Okay, you are asking to why are we not considering the value of f of a equal to 4? Because I have constructed, so I have smartly constructed the array in such a way that you never get a subsequence of length 4. For example, look here. Suppose the value of n is 8. If the value of n is 8, so this is 1, 2, 3, 4. 1, 2, 3, 4. Okay, so I can give you a subsequence, say 2, 4, and 2, which is of length 3. It is palindromic and it is also a subsequence of this array. So you take 2, you take 4, you take 2. Great. So now, okay, so now Garvit, since this was your question, why are we not considering f of a equal to 4? Can you show me one example, one palindromic subsequence in this array, which is of length 4? Can you find the palindromic subsequence of length 4 in this array? Exactly. So I have actually constructed the array in a smart fashion so that I never get a subsequence of length 4. Because whenever I pick some, suppose I picked some two element 2. So in order to make it palindrome, I have to choose this 2. There is no other way. And if I take this 2 and this 2, the only way to keep it a palindrome is I have to choose one of these distinct elements. I can't choose 2. So the longest length of the palindrome I can make is f of a equals 3. The value of f of a can never become 4 because there does not exist any palindrome of length 4. So I need to only consider palindromic subsequences of length 3. When I consider palindromic subsequences of length 3, I see that, okay, the number of palindromic subsequences I get of length 3 is something like this, n into n minus 2 by 4, which is greater than n for all values of n greater than equal to 8. So is that clear? Okay. So now if you look at this question, it says that the integer n lies from 6 to 100. Okay, but we have an answer, we have a solution only when n is greater than equal to 8. So if n is greater than equal to 8, we are done. Nothing new, we are just done. But now there are two more cases remaining. One is n equal to 6 and one is n equal to 7. Right? So what to do for these two cases? Anyone with any idea? What to do if n equal to 6 and n equal to 7? Because for if n is greater than 7, if n is greater than equal to 8, then we are done, right? There are many ways I show you. One is you print till n by 2 and then you again print. Or you just simply print a 1 till n minus 2 and then you again print a 1 or 2. All of these works, like a lot of things work. But what if n equal to 6 or n equal to 7? Any idea? Okay, Amit actually said right. Like for n equal to 6, they have given this solution. So why make efforts? Just print this. So if n equal to 6, why not just print it? So they have said 1, 1, 2, 3, 1, 2. Great. So n equal to 6 is done. What to do if n equal to 7? For n equal to 6, they have given the solution. So they have made life easier for us. Amit noticed it rightfully. For n equal to 7, what to do?
Just add a digit, distinct
Uh,
digit to the sixth answer.
is it? Let's see. So suppose we have for 6, we have 1, 1, 2, 3, 1, 2. And suppose we add one more distinct digit as you said. Let's add 4. Then what is the value of f of a? The value of f of a remains 7. It's 3, right? And what is the value of g of a? the value of g of a is 7. The 7 subsequences they have showed, they have given in this examples they have explained, right? So we do not get any extra subsequence as far as I see. So, but since the value of n is 7, we need to print some answer where g of a is greater than n. So we need to print something where g of a is greater than 7. So just adding an extra 4 seems to not work. So what should I do? Okay, Amit says 1, 2, 3, 4. Okay, I've seen 2 suggestions. Let's try both of them. Anamika says that instead of 4, add 1. So, okay, let me remove this 4. Let me add 1. So, okay, so let me erase this. If I erase this, if I add 1, now what is the value of f of a? The value of f of a is, now we have 4 palindromic. You can see, I can see a palindromic subsequence of length 4. You can pick this one, then this one, then this one, and this one. So the value of f of a itself has changed now. F of a has become 4. And what is the value of g of a? How many subsequences are there of length 4? I can see only one. That is this one, 1, 1, 1, and 1. So the value of g of a is 1. 1 definitely is not greater than 7. So this solution does not work. Okay. So Anamika's solution did not work. Let's try Amit. 1, 2, 3, 4, 1, 2, 3. Let's see this. Okay, so we have a 1, 2, 3, 4. 1, 2, 3. Great. So I see that the value of f of a is 3. We can pick a 1, and then we can pick a 4, and then we pick a 1. And the value of g of a is, what is the value of g of a? So the value of g of a is that we can take this one, and then we will get 3 values. We can take this one, we can again get 3 values. And then we take this one. Okay, no. We can take this one and we get 3 values. Is it? So the value of g of a is 9, it seems. Am I right? Okay, great. So Amit's solution probably works. I do not see any problem here. Okay, so it's 3, 6. Yeah, it works. So 1, 2, 3, 4, 1, 2, 3 is a valid solution for n equal to 7. So you can just print 1, 2, 3, 4, 1, 2, 3, and number of palindromic subsequences. The value of g of a for this is 9, which is definitely greater than 7. So this works. What I did is, you all suggested a lot of things like putting a 4 here or 1 here, but you all missed something this. So basically, like you take 1, 1, 2, 3, 1, 2, and then you put a 2 again. So probably this also works. Like if you look here, the value of f of a is, okay, can someone tell me what is the value of f of a and g of a? If I print this, anyone, if I put a 2 instead of to the 6 solution, I just added 2. Okay. So basically the value of f of a, I guess, remains 3 itself, right? Because we cannot find a palindromic subsequence of length greater than 3. We can just take 3 once. But if you try to find the value of g of a, then what do you do? Then at least I can see one more palindromic subsequence of length uh, 3. So that means apart from the 7 which were already listed here, I see one more palindromic subsequence of length 3. That means I see at least 8. So we are already done. There may be much more, but at least it's greater than 8. So even that works. No, g of a is not 6 here. Is g of a 6? Probably not, because 7 is something which is already mentioned, right? 7 subsequences are already given. And then I can see an extra 1. Yeah, something like that. It's larger than, it's for sure larger than 7. So if you look at the code, it's very simple. I have taken n as input. So I've taken n as input. I've made this vector where I will print. So if n is 6, I just copied, pasted the solution. If n is 7, I did the same thing. I just added a 2. You can also print what Amit has suggested, and there are multiple ways of doing this. And apart from that, I just go from 0 to n by 2, and then I just fill the elements from 1 till n by 2. And for the remaining part, I fill all the values I minus n by 2 plus 1. So basically, when I is n by 2, it prints a 1, and then it keeps on increasing. So that is what it is. Everyone clear with the problem? Any problems? Any doubt? Okay, great. Anyone with any doubt in any of the problems? Okay, great. That's all for today. We will discuss the first 3 problems till C only. Actually, today the difficulty difference between C and D was actually huge. So that's actually sad. Okay, can we do the second question by recursion? Probably we can do. I'm not very sure, but I think we can do. Like it is same as saying that, okay, there we have a bunch of numbers, and then you change the L and R values and make 2 recursive calls, and probably the same thing works. So Anamika, I think we can solve the second question by recursion also. Try implementing it once, the same logic, and probably it should run. Great enough. So that's all for today. Let's end the meet.